In this video, we learn how to solve combination circuit. So let's suppose there is one voltage source and we have resistors in series and parallel. That means it's a combination circuit. So first of all, we need to, let's suppose the question says you need to find out current in each resistor. So first of all, we need to figure out how the resistors are connected. So this is the power supply. I'm assuming, let's suppose this is the direction of current. This is I1 current flowing here. At this point, so I1 will split into two parts. This is I2 and this is my I3. Now I2 goes here, then I2 goes here, I2 goes here. This was I3 coming here, and here I2 and I3 will combine together. So what was the combination? I1 was split into I3 and I2. So that means I3 plus I2 will make I1. So I3 plus I2 will make I1. So that means I1 goes here. Now the basic concept is current in series C. So whenever resistors have same current, that means those resistors are in series. So this means R2 and R3 are in series because the current flowing through R2 and R3 is I2. So R2 is in series with R3. So in series, the resistors are added. So if I redraw the circuit, my new circuit will look like series combination. So where RS represent series combination of R2 and R3. So that is R2 plus R3. So R2 is 3 ohms plus 1, that gives me 4. So RS, I can say R series is 4 ohm. This resistor is R4, that is 5 ohm. This is R1, that is 2. This is R5, that is 6 ohm. Now, if you see this circuit here, you will find that R4 and R series, they are in parallel because this was I1 current here from, I'm following the same above circuit. I1 was here, I3 was here, and on this side, I2 current was flowing. So R4 and R series, they are in parallel. So R parallel will be combination of R4 parallel to R series. So when you have two resistors in parallel, RP will be R4 times R series divided by R4 plus R series. So this is how you find the parallel resistance, equivalent resistance for parallel. So 5 ohms times 4 ohms divided by 5 plus 4. So this gives me 20 divided by 9. So let's do the math. 20 divided by 9, that will give me 20 divided by 9 gives me 2.2. So this means it's 2.22 ohm as RP. Now, if I redraw the circuit, my new circuit will look like this is R1 and this is RP, and now this is R5. So this is I1 current. And you notice that in RP was a parallel combination of R4 and R series. So that forms this RP. Now, they all three are in series. So my R equivalent for this circuit will be R1 plus RP plus R5. So R1 was 2 ohm, RP is 2.2 ohm, plus R5 is 6 ohm. So you do the math. That gives me 10.22 ohms. So equivalent resistance for this circuit is 10.22. So now you have equivalent resistance. That means total resistance. So total resistance that this battery is seeing is 10.22 ohm. So here total resistance is 10.22 ohm. This is total resistance. This is total voltage. So what will be total current? Using Ohm's law, that will be total voltage divided by total or equivalent resistance. So it's the same thing if I say total resistance or equivalent resistance. It's the same thing for the circuit. So 10 volt divided by 10.22. So that gives me 10 volt divided by 10.22 gives me 0.978, 0.978 ampere. So this is the current that is flowing. So that means I total was this total current that is flowing here. So I total means this I1. So I can say that this is I1. We got I1, right? So I will see this is I1 I got. Now, if you see I1 is split into I3 and I2. So we will use current divider rule to find I3 and I2. So what current divider rule says, it will says that I3 is I, that is a total current that flows here. So I can say here I total. Let's suppose I label it as I total times the resistance, because I'm finding R3, I3 in R4. So resistance in series divided by R4 plus R series. So plug in the values. 0.978 times 4 divided by 4 plus 5, that gives me 9. So let's do the math. 0.978 times 4 divided by 9, that gives me 0.434. So this means 0.434 ampere current flows through I3. So we know that this IT was splitting, or I1 I can say, because IT and I1 both are same here. So this current was split into two parts, I3 and I2. So if I have to find I2, I2 will be simply this total current minus I3. So total current or I1, whatever you want to say, I1 or total current minus I3. So I total or I1 is 0.978 minus 0.434. So just do the math here. 0.978 minus 0.434. That gives me 0.54, 0.544 ampere. That is I2 current. So we got I2 current. I2 current was the current that flows from R2 and R3. We got I3 also that flows in R4, and we got R1 current flowing on R1 as I1. I1 and I total is same. So this is how you solve the simple circuit with one voltage source. That's a combination circuit. Thank you.